So now that you've had a couple practice problems, we can come back and recap pretty much, and these next should be pretty easy, with the exception of a few that we had to do together. It says when dividing powers with the same base, just like we discovered up here, you subtract the exponents. And then you'll place the new power in the location of the bigger power. And I'll show you what I mean here in a little bit. All right, so quickly doing this, x to the 12th power divided by x to the 9th power means we are doing x to the 12 minus 9. Notice I moved it to the top of the fraction because that's where my bigger exponent is at. So down here, we're going to put a 1 just as a placeholder for right now. And 12 minus 9 is x to the 3rd power. However, on this one, notice my bigger exponent is on the bottom. So I'm going to do x7 minus 2. And notice I moved my subtraction to happen on the bottom of my fraction. Meaning up here, we now have a placeholder of 1. And then we just do 7 minus 2, which is 5, but we still have that placeholder. So this is 1 over x to the 5th power. And then we get to something that's a little more complicated, not too much, but a little bit more, where we actually have coefficients. So to do this, I like to separate and work with each part separately. 8 divided by 4, I know is 2. And again, bigger one is on top, so that's where my number is going to go. 8 divided by 4 is 2. And then n to 2nd power over just n. So n to the 2nd power minus 1, my little placeholder of 1, would just be 2n. All right, this step right here isn't really necessary. It's just to show you what's actually happening as we're moving along. So let's try it right here without actually doing the step, just doing the math. Again, I like to separate 6 divided by negative 2, negative 3. A to the 2nd power divided by a to the 1st power would just be just one regular a. And b to the 1st power divided by b to the 1st power, well, there's 1 minus 1, meaning they cancel out, and that's gone. So my answer is just negative 3a. And again, let's step it up a little bit more. I like to separate 20 divided by 5, 4. A to the 7th power over just regular a, which is a to the 1st power. So 7 minus 1 is 6, so a to the 6th power. B to the 3rd power over b, 3 minus 1 is 2, so b to the 2nd power, or b squared. And c to the 2nd power divided by c to the 1st power, so 2 minus 1 is 1, or just c. Notice all of these were monomials, both on top and bottom. However, we can do a binomial divided by a monomial. And we're going to do this one a little differently, but pretty much the same. All we are doing is taking each monomial from the binomial on top and splitting it up. So this would be 8n squared over 4n. And then again, take this one and split it up. So negative 36n over 4n. And now we have two monomials just like we did on top, and it's the same process. Split up. 8 divided by 4, 2, n squared divided by n. 2 minus 1 is 1, so just 2n. Split up. Negative 36 divided by 4 is negative 9. N divided by n to the 1st power over n to the 1st power. 1 minus 1 is 0, meaning those cancel out, so here's my answer. All right, let's try one more, and then you'll have a couple to try on your own. Split up the binomial. So 12c to the 5th power over 3c to the 2nd power. And then we also have this other side, 18c to the 4th power, and it's a positive, over 3c to the 2nd power. And I'm going to do this one without actually drawing my little splits, but knowing that 12 divided by 3 is 4, c to the 5th divided by c to the 2nd, 5 minus 2 is 3, so that leaves c to the 3rd power, c cubed. 18 divided by 3 is a positive 6. C to the 4th power divided by c to the 2nd power is going to be c to the 2nd power, c squared. All right, practice a little on your own.